I'm again going back to, because I'm just curious to know more, what alcohol does to, like, what you explained me about the alcohol, right? Does sugar have similar impact?
So sugar is an addictive substance like alcohol. So it hits the same motivational pathway, the nucleus accumbens, so VTA to nucleus accumbens pathway. That's the dopamine producing pathway in your brain. Same circuit also gets hit by sugar. So it's not, your addiction to sugar is also happening through the same circuit.
Okay.
That your alcohol addiction, nicotine addiction, same circuits. Gambling addiction, same circuit. Now, the circuit is vital because without that circuit, you will not survive. Without that circuit, you not remember that you're thirsty and you need to drink, that you're hungry and you need to eat. So that circuit is absolutely vital for survival. But it's also a circuit that is very prone to getting hijacked. So it gets hijacked. It gets hijacked by alcohol. It gets hijacked by drugs of abuse. It gets hijacked by sugar. It gets hijacked by gambling. And it can get hijacked by addictive conditions.
Interesting. And then they all first affect hippocampus and then the ability to actually perform.
They affect multiple parts of the brain, including the hippocampus, prefrontal cortex, accumbens, multiple circuits to different degrees and
the first thing they do is shrinking?
They shrink very often, the dendrites. Sometimes they cause a overgrowth of the branches in areas where you don't want an overgrowth.
Give me an example.
So for example, one of the things that they do is actually they cause an overgrowth in the area of the brain that is called the nucleus accumbens, where you now are hyper prone to responding to the same addictive substance.
Because it gets bigger.
Yeah. So it's not just always that it's causing a breakdown of the structure. Sometimes it's causing it to expand.
And you become hypersensitive to that.
It becomes hypersensitive to the drug. So it can become hypersensitive. It can also become tolerant, such that the same dose of the drug doesn't give you the same response. And so now you need to take twice as much to get the same effect.
Which happens most of the time. Okay. So we clear this and we'll get the
Let's get the microscope. Yeah. So you know the question you asked me, which is, look, it's a rat brain, it's a mouse brain, it's a goat brain, it's a human brain. How can you study a human brain when you're using a rat or a mouse or a goat? Because the building blocks, like I said, are the same.
Okay.
Like if you build a Lego, you can build a small little house with a Lego. You can build a huge plane with a Lego. So in here is the building blocks that I want to show you.
Okay.
So in here is actually a section through the rat brain in which we have stained the neurons. So you can actually see the individual neurons. So I have zoomed in for you. So if you take a look through this, bring your eyes there, you should be able to see these cells. Keep both eyes open and just relax and look.
Okay.
Can you see these black-like dots with these large trees? Almost looks like a forest of trees, right?
Those are just branches.
Branches. That's actually a neuron. Those are neurons in the rat